Hi everybody. Okay, so now we are doing day 2 of sample means, and we are looking similar to what we did with proportions. We are looking at the difference in two sample means. So let's say based on information from the U.S. National Health and Nutrition Exam Survey, the heights in inches of 10-year-old girls follows a normal distribution with a mean of 56.4 and a standard deviation of 2.7. And the heights of 10-year-old boys also follows a normal distribution, but their mean is 55.7 and standard deviation 3.8. Suppose we take simple random samples of 50 girls and 50 boys of this age and measure their heights. What can we say about the difference in the average heights of the girls and boys? So here we're taking the difference where we know for the girls, the mean is 56.4. And for boys, it's 55.7. Right? And when we subtract, we get 0.7. I'll triple check my work, but yep. Okay, and so we know that the difference is 7/10 of an inch, right? Or 0.7 inches. And then second, how do we know this distribution is normal? Well, remember yesterday we talked about the normal condition for one sample. This is the exact same. We know this is normal because 50 is greater than or equal to 30, and that applies for both samples. Okay. So here we're looking at that same data, same information. Describe the shape, center, and spread of the sampling distribution. So the shape will be symmetric because it is normal. Right? And we talked about why it's normal up here. The center will be the mean of x bar 1 minus x bar 2. Well, up here it talks about in our sampling distribution of any difference in sample means, the overall mean is just the difference in the population mean. So that was that 56.4 minus 55.7, which we got 0.7. All right, and then the spread, of course, is the standard deviation of x bar 1 minus x bar 2, sample mean 1 minus sample mean 2. Up here, that gives us the formula. So it's a great big square root of the first standard deviation, so 2.7 squared over n. Well, just n. Plus the second standard deviation squared over 50 as well. All right, so now we're going to calculate that. Square root 2.7 squared over 50 plus, 0.659, so we'll say 0.66. Find the probability of getting a sample difference in sample means of positive 1/10, 0.10 or less. So we know our mean, our average is 0.7. We're looking at 0.10 would be to the left. That's lower than 0.7 or less. All right, so here we have NCDF. We proved it was normal above from negative 1,000 to 0.10 with a mean of 0.7 and a standard deviation 0.66. Is 0.1817, so 18.17%. All right, example 2, a potato chip manufacturer buys potato chips from two different suppliers, Riderwood Farms and Camberley Incorporated. The weights of potatoes from Riderwood Farms are approximately normally distributed with a mean of 175 and a standard deviation of 25, both in grams. The weights of potatoes from Camberley Incorporated are also approximately normal, but their mean is 180 and their standard deviation is 30. When shipments arrive at the factory, inspectors randomly select a sample of 20 potatoes from each shipment and weigh them. They are surprised when the average weight of the potatoes in the sample from Riderwood was higher than the average weight of the potatoes in the sample from Camberley. So, the actual mean of potatoes from Riderwood is lower than the mean from Camberley, but that doesn't mean that you can't have a sample where the Riderwood mean happens to be larger. So let's talk about this. We are going to take the difference between Camberley and Riderwood, C minus R, and look at their shape, center, and spread. Well, the shape, we know automatically, is symmetric because both populations are normal. We don't have to prove, right? In this case, our sample size is only 20, and that's okay because we're pulling from a normal population. Our center, is the mean of X bar C minus X bar R, which is the difference in their means. So 180 for Camberley minus 175 for Riderwood is 5 grams. And then the spread, we're going to use that population standard deviation. C minus X bar R. It's the big square root of 30 squared over 20 plus 25 squared over 20. Is 8.73. All right, find the probability that the mean weight of the Riderwood sample is larger than the mean weight of Camberley. So X bar C is less than X bar R. All right, well, we know this is a normal distribution. We know the center is 5 grams, but we know that for X bar C minus X bar R. Well, think about it. If the Camberley sample is less than the Riderwood sample, then when we subtract them, we're going to get a negative value. We're going to get a value that's less than 0. So we want to go from 0 to the left, right? To do this, we're going to take normal CDF from negative 1,000 to 0 with our mean of 5 and our standard deviation 8.73. Is 0.2834. So 28.34%. So 28.34% of the time, we might get a sample from Riderwood that's actually bigger than Camberley. And that just is because their means are not that far apart. Even though Camberley is bigger, has a larger mean, their overall means are not that different. And so it's not impossible to think that Riderwood could end up being larger. All right, your practice for today is on half sheets of paper. So make sure you get those done. You check for your understanding. And that's it for Unit 5. All done.